Then friends, as you are able to see on the screen, the matrices it is given, the value of matrices 1, it is given 1 omega, omega square, omega, omega square 1, omega square 1, omega being a cube root of the unity, it is given over there. Now we need to find out the determinant of it. Now how we are going to solve that? So see here, let me note down the matrices first. That is 1 omega, omega square, omega, omega square 1, omega square 1, omega. Okay, now up to here I have written the matrices. We need to find out the determinant. But one more thing, it is already in the given data. What is that? Omega is the cube root of unity. Now since omega is the cube root of unity, so one condition also we can know, as we know that since we know what is the condition, 1 plus omega square is equal to 0. Already omega cube is equal to 1. It is the given data. If it is cube root, then these two conditions we are going to follow. If you have any doubt, you can check my previous video for it. 1 plus omega square is equal to 0 and omega cube is equal to 1. Now matrices I have, we need to find out the determinant. Now what I will do here, first I will consider, let me take the first condition, row column. Now first in row 1 I will add row 1 plus row 2 plus row 3. Okay, now what will be answer? See here, this is a row 1. In the row 1 I will add row 1 plus row 2 plus row 3. Now what will be here answer? 1 plus omega square. Next 1 plus omega square. 1 plus omega square. Only I have considered only the row 1. Next will be as it is, omega square 1, omega square 1, omega. Completed. Now after that I will apply the column criteria. So C1 minus C2, column I will minus C1 minus C2, and simultaneously the same line. What else? Let me apply same line, C2 tends to C2 minus C3. Or if you are getting confused, then let me cut this line. Let me do step by step. C1 tends to C1 minus C2. Okay, what is C1? So this line is your C1. C1 minus C2. So everything is same here. 1 plus omega square minus 1 plus omega square. If I minus, how much I will get? 0. Omega minus omega square. So omega minus omega square. Here I will get here omega square minus 1. This column will be same. 1 plus omega square 1, 1 plus omega square, here 1, here omega. Actually we can directly do in the single, means the condition we can put in the single matrix also, the double condition, the column and row. But let me, for your understanding, I am doing it all step by step. Now the next condition I am going to place here, that is your that I am going to place that C2 tends to C2 minus C3. So let me, for your understanding, let me make the same column here, omega minus omega square minus 1. After that it will be here 1 plus omega square 1, 1 plus omega square 1 omega. This is the normal column. Okay, this is a matrix. Same I have written over this there for your understanding. Now we will apply this condition. So again I am writing here, actually this needs to be done here only, but since in the video it will not be possible to show you both the matrices, for that I have repeated here. Now after that, how will I write? C2 tends to C2 minus C3. Now what is the C2? This one, C2 minus C3. Now C1 nothing to do, omega square minus 1. After that, what is the C2 minus C3, and this number both are same, so it will be 0. Now here I will write omega square minus 1, here I will write 1 minus omega, and last number will be same, 1 omega. Now since we got 0 0, so ultimately basically here determinant it will be completely nil, here also determinant will be completely nil. Only one condition that is going to apply, that is your 1 plus omega square. Then this and this minus omega square into 1 minus omega minus this and this. So omega square minus 1 omega square, here it will be minus 1. Clear? Now already bracket should be given here. Now up to here clear? Now what we have learned here 1 plus omega square, how much? 0. So this number will be 0 into entire number. So if I multiply all the number with the 0, so my final answer will be 0. So which option is the correct? Correct option is your that is your E, that is answer 0.